Hello guys, welcome back to my YouTube channel. Today's video we are going to continue on a series which we have started in the previous video, that is on a Kubernetes. So in the previous video we have gone over a brief overview of the Kubernetes architecture and what are all the components of the Kubernetes and how they work together. So in today's video, we are going to discuss about the pods. So in Kubernetes, everything starts with pods. They are the smallest unit you can deploy. But what exactly is a pod and why doesn't Kubernetes just run containers directly? That we are going to discuss in today's video. So coming with the definition of a pod. So what is a pod? Basically, pod is the smallest deployable unit in Kubernetes. So it represents a single instance of a running process. So a pod, think of it a pod as a wrapper around your container. Basically, you are going to run a container. The container will be wrapped inside a pod. The wrapper that provides network and storage context to the container. So the pod can contain one or more containers, usually one main app plus optional sidecar containers. So it's not like that a pod can contain only one container, a pod can have more than one container. So basically pod is a wrapper around your container that provides network and storage context to your container or your process that is running. So why Kubernetes uses pods? So Kubernetes doesn't schedule directly containers directly, so basically, it schedules pods. So what is the benefit of using a pod instead of scheduling directly a container? We will be getting a shared network namespace. So containers can communicate via local host. So we will be getting state. So now you guys might be wondering, why doesn't Kubernetes just schedule containers directly? After all, Docker already does that, right? So while Kubernetes takes container management to the next level. Basically, it needs a higher level of abstraction that groups one or more containers into a single unit that can be deployed or monitored and scaled together. The unit is called a pod. So Kubernetes never schedules containers directly. Instead, it schedules pods, and each pod can contain one or more tightly coupled containers that share the same environment. So, what are all the benefits of using a pod? So number one is the shared network namespace. So all containers inside a pod share the same network namespace. That means they share same IP addresses and can communicate with each other via localhost. For example, if your app containers needs to talk to a sidecar proxy or a log collector, it can just call localhost 8080. So for this, no external networking needed. So the second benefit is shared volume storage. So basically shared storage volumes. So containers inside a pod can also share storage volumes, perfect for scenarios where multiple containers need to read or write the same data files. For example, your main app write logs to var log app.log, and a sidecar container continuously reads it to send to Elasticsearch. Okay, so the third benefit is easier management and scaling. So because pods wrap one or more containers, Kubernetes can manage them as a single deployment unit. So scaling, restarting, and rescheduling and performing all these things on them together. So when you scale a deployment, Kubernetes doesn't create a new container individually, it creates new pods. So a very popular pattern is using a sidecar containers. They are helper containers that enhance or support the main app. Example of a sidecar containers may be logging agent, that is Fluentd, service mesh proxy, NY or Isito, or metrics collector like Prometheus exporter. So this design makes your pod modular and composable, letting you add observability, networking, or storage logic without changing your main app container. So in short, Kubernetes uses pods to group containers that need to work closely together. They share the same network, storage, and lifecycle. So in the next section, we will look how a pod goes through different lifecycle phases inside the cluster. So now we will discuss about the life cycle of a pod. So basically, there are some stages of for the life cycle of a pod that are, let me say, pending, running, succeeded, or failed, or crashback loop off. So basically, we will going to discuss all these things one by one. So the number one is the pending state. So the pod object is created and accepted by the Kubernetes API server the scheduler hasn't assigned it to node yet. So what is a scheduler? What is the work of a scheduler? If you want in detail, you can watch my previous video. So now we can say that if it is in pending state, we can say that the scheduler hasn't assigned it to a node yet, or node is still pulling the container image. So example for this is slow image pulls, insufficient resources may be there, or waiting for PVCs can keep your pod in the pending state. So basically, this is about the pending state. We can say in brief that the pod is created but and accepted by the Kubernetes API server. The scheduler hasn't assigned it to a node yet. So now the scheduler is trying to assign to a node, or node is still pulling the container images. This might be the possible reasons why your pod is in pending state. So the next state, what it is there is the running state. So the pod is scheduled onto a node. So here in the running state, that means that the pod is scheduled onto a node. So the pod is on the node now. So kubelet pulls the container images. So if not already cached, the as we have discussed in the previous video also, the work of the kubelet. So basically kubelet now it has pulled the image and started the containers. The pod containers are now up and running. So the next is succeeded or failed. So succeeded means all containers are successfully exit and won't restart. So failed is one or more containers exited with an error. So the next one, what we are going to talk is a crash book crash loop back off. Sorry, crash loop back off. So it indicates that a containers keep crashing and Kubernetes is repeatedly restarting. So when you see, let's say kubectl get pods, when you hit this command, so you will get crashback loop of something like that. If you describe or something, if you are getting this crash loop back off, so it indicates that the container is keeps crashing. The container is like it's going to create and it's again crashing, and the Kubernetes is repeatedly restarting it. So basically this is a kind of a loop, so where like your container is crashing again and again and your Kubernetes is repeatedly restarting it. So what are all the common causes for this? The causes may be, so these things in the upcoming videos also we are going to discuss in deep. So these scenarios as of now, just understand. So what are the common cases for this crash loop back off? So one may be the misconfiguration. So the configuration what you have given in the YAML that we are going to see in the next step. So you have misconfigured it, wrong commands, missing files, or bad environment variables. So by these things, your container may go in crash loop back off. So the kubelet on each node is responsible for pulling the containers images from the registry, creating the container through the container runtime, monitoring the health and the status, reporting pod status back to the API server. So this feedback loop ensures that the control plane always know each pod's state. So this we have discussed in the previous video also. Now also we are going to discuss. So some common commands for monitoring lifecycle are, let's say kubectl get pods, so kubectl describe pod, kubectl log, and all those things. So now we are going to discuss about pod restart policies. So each pod has a restart policy defined in YAML. So while going, we will see in this, we are going to write a YAML file. So as of now, you will see that we will be having always, on failure, or never. So if it's always, so restart containers regardless of exit code. So if I have given always as a restart policy, it will going to restart always. So on failure is restart only if containers with exit with non-zero code. So basically, if you are aware of the non Linux means zero code means it's executed and well and good. If it is non-zero, there is some problem. So never restart containers even if they fail. So that is the basic about the pod in the Kubernetes, guys. So in the next video, we are going to create a pod. We are going to create a cluster. In that, we are going to deploy a pod, and we will see by using all these commands and all this policy, we will try to do a hands-on on that. So till then, thank you guys. Thank you for watching the video. Thank you for giving your time. Keep watching my YouTube channel. Guys, please support my YouTube channel. Please like, share, and subscribe the video.